So we have the equations of these two lines, and we would like to see if they have a point of intersection. So first step would be to go ahead and set the values of x coordinates, y coordinates, and z coordinates equals. So let me erase this portion and solve for t and s and see if we have a consistent solution of that system, or the system is consistent, in other words. Okay, so here we go. Okay. That is, we set the parameterizations of x coordinates, the y coordinates, and z coordinates equal to each other, and then we are going to see if they correspond to a consistent system of equations. So what we will do is this, that we will solve two of these three. For example, let's take this one, and out of many ways of solving it, one of them is we can go ahead and add the two equations. So if we add these two, what will happen? I get a 3 on left hand side, and I get 5 minus s on the right hand side. So if we solve for s, what we will get is simply s equals 2. And once we get s equals 2, we can use any of these two equations that we have taken up, and then just write s equals 2 in here, and what we get is t equals -1. Okay, and now this was the third equation. So we will see if these coordinates satisfy the third equation. If they do, then we will have a consistent system and a solution is available. Okay, so we will just give me a moment. Okay, so we will write t equals -1 and s equals 2, and we can see this corresponds to 1 equals 1. So therefore we have a consistent system of equations, and the solution, or the lines will intersect at points that correspond to s equals -1, t equals -1 and s equals 2. So all we have to do now is, just obtain the original equations of the lines. All right, and just put t equals -1 here. Here we got -1. Okay, and here we have -1 again. So this corresponds to which point? 1, 2, 1, right? X is 1, y is 2, and x is 1. And if we put s equals 2 in here, you can see we will get the same point here again. That is simply, so s equals 2. So this also produces the point 1, 2, 1, 1 here. And we have a computer package called MATLAB in our computer lab. So if you want, you can check your solution by graphing these two lines in MATLAB in the following manner. So in MATLAB, let's go ahead and take the values of t, our parameter, between -10 and 10, and let's take 200 sample points. All right, put a semicolon so that we don't get a whole list of values. All right, now what our values were here? Okay, our values were, okay, let me get our values back here. That is, we have x1 equals, just give me a moment. So we had x1 equals 2 plus t, all right, because we are going to take x1, y1, z1 to be able to plot both these in the same window. So y1 equals 1 minus t, okay, and then we have z1 equals -2 minus 3. Here is the product sign, t. Now this s, we are going to write that as t as well, and to distinguish we'll just label those as x2, y2 and z2. So we got -1 plus t, and then we have y2 equals 6 minus 2 times t, okay, and z2 equals -3 plus 2 times t, okay. And now we are going to ask it to give us a 3D plot of these coordinates parameterized by t in one window, and let's see what we get. Okay, so here we go. So, and you can, so here we got a graph. All right, we can use this window to see that the lines intersect, right? And you just check it out that which point they intersect at. All right, so, or you can check it out algebraically pretty easily in this case. All right, so let's take up another example. So here we are going to see if these two lines intersect or they don't. So as before, actually it is slightly different than before. Here we have to solve for x and y and z, okay. So this gives us what? This gives us that wait a second, this gives us that x is 2 plus 3t, all right, and y is -1 minus t, all right, and z is how much? Z is 1 plus t, okay. And so here we have, and likewise x will be 2 plus s, y will be 2 plus s, and z will be 3s plus 1. So as we did before, we shall set 2 plus 3t equals what? S plus 2, all right, and we shall put, we shall set this -1 minus t, okay, equals here also y is s plus 2 again, okay, and then at the end z is 1 plus t, okay, and then z here is what? 3s plus 1, okay. So if I did this, took say these two equations, okay, and solved these two, there are many ways of doing that, but one is we can simply subtract the bottom equation from the top and obtain 3. 2 minus 1 is 3, and then we get, by subtracting these here, we get 4t, and on the right hand side we have a 0. So what does this give us? This gives us that t is negative 3 over 4. Okay, so when t is negative 3 over 4, okay, then let's see what s will be. Okay, so t is negative 3 over 4, and I'm just going to automate this computation because you know how to solve such equations. Okay, so solve exact. So this is negative 9 over 4, and in order for the solution to exist, what we should have is that we should have these two values satisfy this third equation. Okay, so let's see if that works out or not, or it does not. Okay, so there we go, and doesn't look like that this is going to match. You can check it out. All right, so these lines, they do not intersect. Okay, so what we are going to do is, as before, we can go to MATLAB, all right, and just see, just look at a graph of whether these two lines intersect or they don't. So here for x I got 2 plus 3t, and for y I have negative 1 minus t. So I'll go to MATLAB, okay, and I will take these as, say, x3 equals, let me type these in and come back to you. So here what I have done is that I put x3 y3 z3 and x4 y4 z4 according to our new line. Okay, and now I'm going to plot x3 y3 z3 x4 y4 and z4 in the same window. Okay, so let's see what our graph looks like. So the graph looks like this, and we can rotate it to see that you can see these two lines are what you can call skew lines, that they don't intersect. All right, okay. So yeah, let me know if you have any questions, or I'm really tired. So if I made a mistake along the line of calculations, let me know that as well. All right, so see you later. Thanks.